Hi there. In the world of tech, we just love our acronyms, right? But what happens when the same three letters pop up in two totally different, world changing fields? Well, that's what we're diving into today, the curious case of the TSU. It's an acronym that's making some serious waves in both artificial intelligence and chemical engineering. So let's unpack this thing. And we're kicking things off right in the heart of the tech revolution, generative AI. I mean, this field is just moving at a mind-blowing pace. But as it gets bigger and bigger, it's running headfirst into a massive wall. And that wall, well, people are starting to call it the AI energy wall. Just think about it for a sec. The AI models we have right now, they're just the beginning. If we want to put that kind of power into the hands of everyone on the planet, we need more electricity than we can possibly generate. Seriously. It's this hard limit on the future of AI, and it's a huge, huge challenge to overcome. But what if there was a way to just smash right through that wall? A startup called Extropic is making this incredibly bold claim. They're developing a whole new kind of chip, one that could be up to 10,000 times more energy efficient for AI. Now, that's not just some small improvement. That is a complete game changer. Okay, let's dive into this. This is the first TSU we're going to talk about, and its entire mission is to tear down that AI energy wall. And it's not just a tweak on what we have now, it's a complete rethink of how we build computers for artificial intelligence. So what in the world is this TSU? Well, it stands for Thermodynamic Sampling Unit. Now, the key word here, the one you really gotta latch onto, is sampling. See, your computer's CPU, it's basically a calculator. It's designed to give you one right answer. A TSU, though, it's more like a storyteller. Its job is to explore a whole universe of possibilities and then pick out the most likely ones, which is exactly what generative AI does when it creates an image or, writes a sentence. In the heart of this TSU is something called the p-bit, or probabilistic bit. Now, what's so wild about this is how it works. A p-bit is an analog circuit that does something brilliant. It harnesses the physical noise, the random electronic jitters, that engineers usually spend billions of dollars trying to get rid of. They've literally turned a bug into a feature. They use that natural randomness to efficiently spit out a 1 or a 0, but with a precise, programmable probability. Okay, so how do all these pivots actually work together? Well, in AI, there's this massive mathematical hurdle called the Z problem. Basically, to make a perfect decision, an AI would need to consider every single possibility in the universe, which is, you guessed it, literally impossible. But the TSU has this super clever workaround called Gibbs sampling. So instead of trying to see the whole giant picture all at once, each little pivot just looks at its immediate neighbors. It's kind of like a giant game of telephone, but one that actually works. In the end, it produces a coherent, useful result without ever having to solve that impossible Z problem. Pretty smart, huh? And that could be the end of the story, a super fascinating new chip for AI. But here's the twist. If you've been working in a totally different corner of the science world, you've known about the TSU for years, and it has absolutely nothing, and I mean nothing, to do with AI. All right, let's step out of the digital world of silicon chips for a moment and walk into the very physical world of chemical plants. Because over here, another TSU plays a critical role. But this one is all about keeping people safe from some very real, very physical dangers. So meet the other TSU, the thermal screening unit. And as you can see, we are not talking about microchips anymore, not even close. This is a rugged piece of lab equipment built to handle some serious pressure and temperature. It's a tool for figuring out what happens when you mix chemicals together, and, more importantly, how to do it safely. And its whole purpose is to keep people safe. See, when a company wants to scale up a chemical reaction from, say, a tiny lab beaker to a massive industrial tank, the physics change a lot. This TSU is a screening tool. It lets them test just tiny samples, like a few grams, to measure exactly how temperature and pressure change during a reaction. This way, they can spot potential hazards before they happen on a massive and potentially very dangerous scale. And this right here, this shows you exactly why that is so important. This is a graph of something called thermal runaway. It's what happens when a chemical reaction just goes completely out of control. As you can see, the temperature just shoots through the roof, and that can lead to fires, explosions, basically a disaster. The TSX is the tool that gives scientists the data they need to make sure this never happens. So here we are. We've got two pieces of cutting-edge technology, both called TSU, both using thermodynamics in some way, but they exist in completely separate universes. So let's put them side by side and clear this up once and for all. Okay, let's break this down. The AI TSU, it's a digital tool for creating new things for generative AI. The chemical TSU, it's a physical tool for preventing bad things from happening. One works with bits on a microchip, the other with chemicals in a beaker. They're both at the absolute cutting edge of their fields, for sure, but they are solving completely, totally different problems. Now, whenever a powerful new computer technology like the AI TSU gets announced, you see the buzz online, right? And one question always comes up. Could it break Bitcoin? So let's just tackle that one head on. And the answer is a very clear, very simple no. And here's the reason why. A TSU is a specialist. It's not a jack of all trades. It's absolutely brilliant at one thing, sampling. But that's not the skill you need to break encryption. Not at all. And plus, the sheer raw power required to crack something like Bitcoin is, well, it's astronomical. A TSU, as efficient as it is, just isn't in the same league. It's kind of like trying to win a marathon with a Formula One car. Sure, the car is powerful, but it's the completely wrong tool for the job. So, after exploring these two very different worlds, what's the big takeaway here? Why does this whole distinction even matter? Well, the big takeaway is actually pretty simple. Context is king. In our world of nonstop innovation and buzzwords, it's so easy to get lost in the jargon. But as we've just seen with the TSU, the same three letters can mean two completely different world-changing things. It's just a powerful reminder to always look beyond the hype and understand what's really going on. So let's just lock this in one last time. The AI TSU is a thermodynamic sampling unit. It uses physics to make AI way more energy efficient. The chemical TSU is a thermal screening unit. It uses physics to make chemical manufacturing a whole lot safer. The bottom line, both are incredible cutting-edge innovations, but they operate in completely separate worlds. So the lesson here is always check the context. So there you have it, the story of the two TSUs. It kind of makes you wonder, right? What other amazing breakthroughs are out there? Maybe hiding behind an acronym we think we already know. Thanks for joining me on this explainer. See ya.